Hi, my name is Cihat Acar. I made the pseudocode and contributed to the report.
Hi, my name is Lisa Mukaria and I made this video presentation.
Guten Tag, my name is Daniel von Hainisch and I provided the flow chart for the Python code.
Hello, my name is Jofi Katana and I wrote the report.
Hi, my name is Taina Ahala. I wrote the Python code.
Our group was tasked with creating a Python program that is able to determine whether or not the inputted digits are of a valid credit card.
To do so, we were provided with some information on how to manually determine the validity of a card. The steps are the following.
Take a credit card number and, for example, let it be this.
Then double every second digit from right to left.
If doubling of a digit results in a two-digit number, add up the two digits to get a single-digit number.
Then we add all the single-digit numbers from the previous step together.
Next, add all digits in the odd places from right to left in the card number.
Lastly, add up the results from the previous two steps.
If the number is divisible by 10, then the card is valid. Otherwise, it's invalid.
Before we jump into the code, here's some background on who came up with the algorithm and why.
In 1954, Hans Luhn, a researcher in the field of computer science, while working for IBM, proposed an algorithm for validating credit card numbers. The intended purpose of the algorithm was to determine whether a credit card number is entered correctly and is valid.
Today, credit card numbers are generated following this validity check, which is also known as the Luhn check or the mod 10 check.
In order to tackle this task, we utilized the formula equation strategy since we were provided with the mathematical steps of mod 10 check.
To begin developing the code, we got familiarized with already known information about all credit cards. That is, that the credit card numbers usually follow a pattern, and there are between 13 and 16 digits in every credit card.
We additionally know that a Visa card begins with a 4, a MasterCard begins with a 5, an American Express card begins with a 37, and a Discover card begins with a 6.
The next step was to determine what specifically our code was going to do in order to proceed with the flowchart and a pseudocode for the program.
The task of the program is the following.
The user inputs their credit card number, and in return the code displays the digits of the credit card number as individual elements of the list, then informs whether or not the card is valid. If the card is valid, then the service of the card is printed.
Here are the pseudocode and flowchart that were created based on the task and the mod 10 algorithm.
And here is the code that goes with the pseudocode and the flowchart.
First, the request for input is printed, and the input gets stored in the variable called credit card number as a list. The strip function is used to get rid of possible blank spaces at the start or the end of the input. If the credit card number is longer or equal to 13 and shorter or equal to 15 digits, then an empty list called processed digits is created for the doubled and otherwise processed digits. In the if statement for index and digit in enumerated credit card number list, if the index is equally divisible by 2, or in other words even, then the number in the index gets multiplied by 2 and the result is stored in a variable named result. In the same if statement, where a number is even, if the variable result is more than one digit long, in other words if the number is greater than 9, then the digits of that number are added together. Then, an empty variable called sum of digits is created for the sum of the two digits and is assigned value 0. The digits in the variable result increment the variable sum of digits, and the sum of digits is appended into the list named processed digits. Else, if the result is one digit long, then the variable result is appended into the list named processed digits. Else, if the number of digits in the credit card is not even, thus odd, then the odd index numbers are appended into the list called processed digits. Next step is to sum up the numbers in the list process digits, and store the result in a variable named sum of all numbers. If the sum is divisible by 10, then the credit card number is valid and the print function displays that the credit card is valid. After the credit card was confirmed to be valid, the card service is determined. If the credit card number starts with a 4, it is a Visa card and the print function displays that the credit card is a Visa card. If the credit card number starts with a 5, it is a MasterCard. If the credit card number starts with a 3 and the second digit is 7, it's an American Express card. If the credit card number starts with a 6, it's a Discovery card. If the credit card does not begin with either of the above mentioned digits, yet is still determined as a valid card, then the print function displays that the card service is unknown. If, however, the variable sum of all numbers is not divisible by 10, then the credit card is not valid and the print function displays that the card is invalid. Lastly, if the credit card does not meet the length requirement, then the credit card is invalid. Here is a trial run of the code. We first try the invalid credit card number that was introduced in the example in the beginning of the video. The second test is done with a valid card. The digits are displayed as individual elements of the list and then confirmed to be valid and a Visa card.
Although the algorithm to work by was mostly provided in the task, we had minor difficulties translating the process in the code. We encountered the following problems.
Constant change in data type needed, as we both use numbers for calculations and strings to iterate through and print in sentences as answers.
We needed to use functions in Python that we weren't very familiar with, for example, enumerate, therefore we had to do some research before completing the code.
Generally, we could say that most of our difficulties stemmed from the fact that the algorithm was not always easy to translate into the programming language. To help us see more clearly, we first spent time understanding the problem completely, rephrasing it into clear algorithmical operations.
Then, we divided the task into subproblems, which included finding a way to iterate through odd and even index number digits in the account number, adding these digits and adding the two sums.
Therefore, the most prominent parts of problem-solving process was understanding the problem perfectly and finding a solution by dividing it into smaller subproblems.